6th grade, Module 5, Lesson 19A, Problem Set. This problem set is a culmination of skills learned in this module. Note that the figures are not drawn to scale. All right, calculate the area of the figure. So we have a parallelogram, and to find the area of a parallelogram, remember it's the same as a rectangle or a square. So area equals base times height, because we could basically just take this piece off and put it right here, and then we basically do have a rectangle. So that's why this formula works. So base times height, it looks like the base is 40 feet, the height is 20 feet. So 40 feet times 20 feet would be equal to 4 times 2 is 8 with 2 zeros, so 800 feet squared. Calculate the area of the figure below. So here we have a triangle. Remember, the area of a triangle is 1/2 base times height. So we have 1/2. The base is this whole distance right here, and we need to add those together. So 5/10 plus 8/10 would be 1 3/10 meters. So the base is 1 3/10 meters times the height. Remember, we want the height or the altitude of the triangle is 1 2/10 meters. So we need to do 1 3/10 times 1 2/10. Two digits behind the decimal points, move it over 2 places. We get 1 56/100. So we have 1/2 times 1 56/100. So let's find half of that. I'm just going to divide it by 2. Bring the decimal point straight up. 2 can't go into 1, but it can go into 15 7 times. And 2 goes into 16 8 times. No remainder, nothing to bring down, so we get 78/100 meters squared as the area. Number 3, calculate the area of the figure below. So there's multiple ways to do this. I'm going to break it into, let's go like that. So we'll have triangle A and triangle B. So find the area, or rectangle A and rectangle B. So find the area of both of those, and then we'll add the areas together. So A, triangle A, the area would be, let's see, base times height. So here's the base. The whole thing would be this 18 plus 7. So 18 plus 7 would be 25. So we have 25 inches times the height is 12 inches. And then rectangle B would be the base is 7 inches times the height. Let's see, they haven't given us the whole height, but they told us this whole thing is 32 and this part is 12. So 32 minus 12, this would be 20. Okay, so let's do 7 times 20 first. So 7 times 2 is 14 with a 0. So that is 140 inches squared. And then A, 25 times 12 is 300 inches squared. So we just need to do 300 inches squared plus 140 inches squared, and we would have 440 inches squared as the total area. Number 4, complete the table using the diagram on the coordinate plane. Okay, so we need to plot the points, or label the points, find their distance, and then prove their distance. So we have line segment AB. So AB is here to here. So A looks like it's at -1, 2, 3, 4. -4, and then up 1, 2, 3, 4, 5, 6, 7, 8. So we have negative 4, 8, and then B is at 1, 2, 3, 4, 8. So then for the proof, remember we're looking for where they differ. So their 8s are the same. So we're looking at the 4, the negative 4 and the 4. So our proof, if anything is negative, we're going to find the absolute value of both of them. If they are on different sides, remember, so if they're on opposite sides, meaning in different quadrants, so quadrant 1, 2, 3, and 4. So if they're in opposite quadrants, then we're going to add. If they are on the same quadrant, then we're going to subtract. So these are on opposite ones, which means we're going to add. So we're going to do the absolute value of negative 4 plus the absolute value of 4 is equal to 8. So their distance is 8. You could also just count. So you could see the distance is 1, 2, 3, 4, 5, 6, 7, 8. All right, CE. So we have C and E. So C is at 1, 2, 3, 4, 5, 6, 7. So it's at 7, 8. E is at 7, 1. So they differ here on the 8 and 1, but they're in the same quadrant, so we're going to subtract them. So we have the absolute value of 8 minus the absolute value of 1 is equal to 7. GI. So here's G, here's I. So G is at 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. So 5, negative 5. And I is at negative 1, 2, 3, 4, negative 5. Negative 4, negative 5. So they are different, and 5 and negative 4, and they're on opposite sides, which means we're going to add them. So the absolute value of negative 5 plus the absolute value the absolute value of 5. Doesn't matter, they're both going to be 5, but let's make sure we get it right. Absolute value of 5 plus the absolute value of negative 4. 5 plus 4 is 9. HI. H, where is I? Right over here. Okay, we already knew I was negative 4, 5. Negative 4, negative 5. H is 2, negative 5. So they are different in their x values, and they're on opposite sides, so we're going to be adding them. So the absolute value of 2 plus the absolute value of negative 4 is equal to 6. IJ. Here's I. Here's J. Okay, so I is negative 4, negative 5. And J is negative 1, 2, 3, 4, 3. So here their y values are different. They're on opposite sides. You can tell if one is negative and one's positive. So we're going to add negative 5, absolute value of negative 5 plus absolute value of 3 is equal to 8. AI. So again, we have an I. Let's do negative 4, 3. Or no, sorry. I is negative 4, negative 5. And A, let's look, AI. It's all the way here, all the way down there. A was right here, it was negative 4, 8. So they differ on their y values, and they're in opposite coordinates or quadrants, so we're going to add them. Absolute value of 8 plus the absolute value of -5 is equal to 13. And then the last one, AJ, so A was -4, 8, and J, here's A, where's J? Right here. J is -1, 2, 3, 4, 3. So they differ on their y coordinates, and they are on the same coordinate, the same quadrant, so we're going to subtract them. Absolute value of 8 minus the absolute value of 3 is equal to 5, so the distance is 5. All right, number 5. Plot the points below and draw the shape, then determine the area of the polygon. So we have A, -3, 5. -3 is right there, and then up 5. There's A. B is 4, 3. 4, up 3. And C is 0, -5. So 0. Okay. So I'm going to connect these. All right, so I don't see a clear length, width, and height here. So what I'm going to do is I'm going to make a rectangle around the outside here. And it's going to be simple to find the area. We can find the area of the rectangle and then find the area of all of these right triangles. And then we can subtract to find the area of the middle. See, all of these are going to be easy to find because they are right triangles, so it's easy to see their length and width. So let's call this 1. Oops. 1, 2, and 3. First, let's find the area of the rectangle. So the length is 1, 2, 3, 4, 5, 6, 7. And the height is 1, 2, 3, 4, 5, 6, 7, 8, 9, I believe. We count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nope, it's 10. So 7 by 10. So the area of the rectangle, base length times width, is equal to 7. We don't know what it is, so let's call it 7 units by 10 units, which is equal to 70 units squared. So the area of the rectangle is 70 units squared. Now let's do triangle 1. I'll call it triangle 1. So the length, the base area is equal to 1/2 base times height. So we're going to have 1/2. The base is 2, or we can call it 1, 2, 3, 4, 5, 6, 7. We already knew that was 7 by 2. So 1/2, 7 by 2, or 1/2 of 14 is equal to 7 units squared. And so let's do triangle 2 here. So 1/2 base times height, 1/2. The base of 2 is 1, 2, 3, 4 by, the height is 1, 2, 3, 4, 5, 6, 7, 8. So half of 32 would be equal to 16 units squared. And then let's do triangle 3, this one. 1/2 base times height. The base is 1, 2, 3. And the height is the whole thing which was 10. So half of 30 is equal to 15 units squared. So now we have all this, we know what the whole thing is, we know what the surrounding things are, so we're just going to take the rectangle, the whole rectangle, and subtract all of these units out. So we have 70 units squared minus 7 units squared minus 16 units squared minus 15 units squared. So let's see, let's do 70 minus 7 would be 63 minus 16 minus 15. We are left with 32 units squared. And that is the remaining area, which means that this is 32 units squared. All right, number 6. Determine the volume of the figure. So remember, volume is equal to length times width times height. So we have the length is 3.5 meters times the width is 7/8 meters times the height is 1 1/4 meters. Now they are all fractions, so I'm going to convert them into improper fractions. So 3.5 would be 7/2 times 7/8 times 5/4. So 7 times 7 is 49, and 49 times 5 is 245. Over 2 times 8 is 16. 16 times 4 is 64. But let's make that back into an improper fraction, or a mixed number. 245 divided by 64 can't go into 24 or 2, so let's see, let's try 64 maybe times 3 or 4. Let's try 3. I don't think it could go in another time, but let's just make sure. Yeah, 256 is too big, so it only goes in 3 times. That was 192. 14 minus 9 is 5. So we get 3 with 53 left over. Out of 64. So this is equal to 3 and 53 64ths meters cubed is the volume. Give at least 3 more expressions that could be used to determine the volume of the figure in problem 6. So we could have done, we did 3.5 by 7/8 by 1 1/4. You can rearrange them. So you could say that it's equal to 7/8 meters times 3.5 meters times 1 1/4 meter. You could also find the area of the base. So do 3.5 by 7/8. So 3.5 times 7/8 would be, let's see, 7/2 times 7/8 will be 49/16. So we could say 49/16 meters squared times 1 1/4 meters. There's another one. Or we could find the area of this base and do, let's see, what is 7/8 times 1 1/4 is 5/4. That is 35 30-seconds. So you could also say 35 30-seconds meters squared times, which one didn't we use? 3.5. So it's all just different ways of mixing up that expression. Number 8, determine the volume of this irregular figure. Okay, so you can either break it into 3 places right here, or I think what I'm going to do is I'm going to make it into 2. So we'll have the back rectangular prism and the front. Okay, so let's do A and B. So the volume of A, length times width times height. So the length is 3 5/8 feet times the width is 1 1/3 feet. And the height is 1 1/4 feet. And then let's find the dimensions for B also while we're at it. So B, the length says is 1 1/4 feet. The width here is 1 1/6. And the height is the same all throughout, is 1 1/4. Okay, I'll start with B since I'm already on B. So let's do 1 1/4 is 5/4 times 1 1/6 is 7/6 times another 5/4. So we have 5 times 7 times 5. So let's do 35 times 5. It's 175. And 4 times 6 is 24. 24 times 4 is 96. So we have 175 and 96 feet squared. I'm going to stick with that, and then if I need to convert it into anything later, let's see what we get for A. So A was 3 5/8, so that would be 24 plus 5, 29/8, times 1 1/3 is 4/3, times 1 1/4 is 5/4. So 29 times 20. Let's do it. It's 580. And then 8 times 3 is 24. 24 times 4 is 96. So that's great, because what we need to do is add these together. It's wonderful they have the same denominator. So let's do 580 96 feet squared plus 175 96 feet squared. So 580 plus 175 is 755 96. And we just need to make that back into a mixed number. So 755 divided by 96. Can't go into 7 or 75, but 96 could probably go into 755 7 or 8 times. Let's try 7. Seven times 9 is 63 plus 4 would be 67. So 672. Could it go in another time? Let's try 96 times 8 just to be sure. 9 times 8 is 72, plus 4 is 76. So 768 would be too big. So it only goes in 7 times. I'm going to subtract. 15 minus 7 is 8. So we get 7 with 83 left over out of 96. 7 and 83, 96 feet squared. Sorry, cubed. So all that work. Finally found the volume. Okay, number 9. Draw and label a net for the following figure, then use the net to determine the surface area of the figure. Okay, so we have a rectangular prism that's 10 by 7 by 12. So I'm going to start by drawing this front face here. And it is 10 by 12. So this is 10, this is 12. Next to it, or on top of it, is one that is 7 by 10. So this is 10, this is 7. So I'm going to connect one on here, 10 by 7. And then the back connecting to it is going to be the same as the front face. So I have another 12 by 10. And then this bottom is going to be another 10 by 7. 7 by 10. Now we just need to add these sides. So we can add a side that is 12 by 7 really anywhere. I'll add it, let's see, this is 12. This one is 7. I'll add 12 out the side here. So that is 7 by 12, and then put another one on the other side, 7 by 12. So there's a net. Yours might look different. That's okay. So it wants us to use this to determine the surface area of the figures. Remember, the surface area is the area of all the faces combined. So this would be 12 by 10, or 120. This is all centimeters squared. This will be 120 centimeters squared. 7 by 10 is 70. 7 by 10 is 70. And 7 times 12, I think is 84. It's 84. So let's add all of those together. We have 120 centimeters squared plus 84 centimeters squared plus 70 centimeters squared plus 84 centimeters squared plus 120 plus another 70. Okay, so we just need to add all of those together. I'm going to add the ones that are alike first. So 120 plus 120 would be 240. 70 plus 70 is 140. And 84 plus 84 is 168. Let's do 240 plus 140 plus 168 is 548 centimeters squared is the total surface area. Determine the surface area of the figure in problem 9 using formula. The surface area is equal to length times width times 2 length plus 2 length times height plus 2 width times height. Then compare your answer. So surface area is equal to 2 length times width. Let me get rid of some of this. Okay. 2 length times width. So length times width is 10 centimeters times 7 centimeters plus 2 groups of length times height. So 10 by 12 plus 2 groups of width times height. So width times height is 7 by 12. So we have 2 times 70 centimeters squared plus 2 times 12 times 10 times 12 is 120 centimeters squared plus 2 groups of 7 times 12 was 84 centimeters squared. So we get 140 centimeters squared plus 240 centimeters squared plus 168 centimeters squared. And when we add all those together, we've already done it, is 548 centimeters squared. So then it wants us to compare your answer to the solution in problem 9. So the formula just helped us do what we did up here in problem 9. As you can see, we compare them, they are the same. So here, the two groups of 10 times 7 were two groups of 10 times 7 right there. Two groups of 10 by 12. 10 times 12 was 120. And then two groups of 7 by 12 was 84. That one got erased somehow. So they're the same. The formula was just a way to do it without a picture and a way to do it with just numbers. So let's say they are the same. Answers. The formula finds the areas of each pair of equal faces and adds them together like we did with the net. Number 11, a parallelogram has a base of 4.5 centimeters and an area of 9 and 495 centimeters squared. Tanya wrote the equation 4.5x equals 9 and 495 thousandths to represent this situation. Explain what x represents in this situation. So x here is representing, so it has a base. Well, to find the area of a parallelogram, we do base times height. So if we know the area and we know the base, then the h is what's missing. So the x is representing the height. And then b, solve the equation. So 4 and 5/10 x is equal to 9 and 495 thousandths. So to get rid of the multiplication, we're going to divide. So 9 and 495 thousandths divided by 4 and 5/10. I'm going to move the decimal point over one spot and then bring it straight up. So 45 can't go into 9, but it could go into 94 twice, because 2 times 45 is 90. Bring down the 9. 45 goes into 49 once. And 45 goes into 45 once, with no remainder. So we get 2 and 11 hundredths. So x is equal to 2 and 11 hundredths centimeters, or the height. So let's say the height is 2 and 11 hundredths centimeters. And the last one, number 12. Triangle A has an area equal to 1/3 the area of triangle B. Triangle A has an area of 3.5 square meters. Gerard wrote the equation b over 3 equals 3.5. Explain what b represents in this equation. So we want to know what b represents. We know, let's just write down what we know. Sometimes if a question's a little confusing, so we know that triangle A has an area equal to 1/3 of triangle B. And A is equal to 3.5 meters squared. So we could say that 3.5 is equal to 1/3 of B. But what it looks like they've done is they just put B over 3, which is the same thing. 1/3 of B, finding 1/3 of the B of B is the same thing as doing B divided by 3. So what is B representing? Well, B is representing the area of triangle B. So B represents the area of triangle B. And we're talking in square meters. So then B, determine the area of triangle B, so we just need to solve. So 3.5 is equal to B divided by 3. So we can get rid of that by multiplying by 3. So that'll cancel that out and leave B alone. But then we need to do 3.5 times 3 is equal to B. So 3.5 times 3, well, 3 times 3 is 9, and 1/2 times 3 is equal to 3/2. So if we add that together, that's equal to 10.5 is equal to B, or 10.5 meters squared is the area of triangle B.